Welcome to the day 5 notes. This is our third video, but day 5 notes. So I'm going to have you pause the video, do these couple warm-up questions, and then come back and see how you did. So first off, I know that I've got everything over 2 on this side, so I'm going to change that 7 to a 14 over 2 to find a common denominator. Then I'm going to subtract 14 over 2 from both sides. When I do that, I'm going to get minus x on the left. On the right side, I'm going to get minus 9 over 2. You could either divide both sides by -1 or multiply both sides by -1. Either one's fine. They do the exact same thing. They just change the sign. So my answer is 9 over 2. Okay. If you write 4.5, that's okay, but it's literally less work to just leave it as a fraction. This one over here, there's 2 ways you can solve it. I'm going to do both quick. You can distribute to get 60 minus 24x equals 6, minus 60 from both sides to get minus 24x equals negative 54. Divide both sides by negative 24 to get x equals positive 54 over 24. But then I simplify. If I divide both of those by 2, that would be 27 over 12. But I can divide both of those by 3 to get 9 over 4. That would be my answer. The other way we could do this problem is divide everything by 12 at the beginning. That'll cancel those out because they make 1 times that set of parentheses. So we get 5 minus 2x on the left. Then 6 over 12 is 1/2. And then I could subtract 5 from both sides. I get minus 2x equals, well, minus 5 is the same thing as minus 10 over 2. So that would give me a negative 9 over 2. Okay, and then when I divide both sides by -2, that's like multiplying by negative 1/2. All right, so that would be x equals negative divided by negative is a positive. And I would end up with the exact same answer. All right, so today we're going to be talking about 1- and 2-step linear inequalities with graphs. So first off, an inequality in one variable describes a relationship in which 2 expressions are not equal. One expression can be either larger or smaller than the other one. Sometimes you'll have inequalities that imply greater than or equal to, or less than or equal to. So greater than or equal to symbol looks like that. Less than or equal to symbol looks like that. So for these first few, the graph of the linear inequalities in one variable is the set of all points on a number line that represent all solutions of the inequality. So first we're going to come up with the inequality, then we're going to find the graph. So all real numbers less than 2. All real numbers, that's the thing that gets to change. Which number is it going to be? That's my variable, so I'm going to say x in this case. They're all less than 2. So x is less than 2. So on my graph, I'm going to always need 2 specific numbers. The first number is 0. I always need to see a 0. Okay, I don't really care where it's at on the number line. It could be far right, far left, in the middle, whatever, but I need a 0. Then I also need at least this number on the number line in the correct place. So I could put a 2 here, I could put it there, I could put it there. Doesn't really matter as long as I'm consistent. What I mean by that is if I put a 2 here, that would have to be a 4 and that would have to be a 6. This would have to be a -2, and so on, because you're saying you're going by 2s. Okay, I'm going to put it here to imply that we're going by 1s, and that's enough for me. Now, if x does not equal 2, okay, or equal to part would be like that. If it does not equal, I put a big circle above the number line. All right, and then if I have x on the left side, whatever way this thing points, if I pretended that's an arrow, I'm going to draw an arrow going that direction. All right, so we're going to see a few more example problems to see what that looks like. As I stumble over my words, I apologize. So now it says all real numbers greater than -2. All real numbers, that's my x, is greater than -2. So I need a 0 and I need a -2. Okay, does not equal, so I put a circle above -2 and the arrow points to the right. What we have to be careful on is if I say 2 is greater than x, this and this are the exact same thing. X is less than 2 or 2 is greater than x is the same thing. if x is on the left, you get the little cheater reminder of what direction the arrow points. That does not work if you have x on the right side. All right, if you could write either one of those down and then have that picture to get full credit. Okay, same thing kind of goes here. If I had done -2 is less than x. Those are the same. That's the picture that represents it. Next one is all real numbers less than or equal to 1. Less than or equal to symbol looks like that. Still need a 0, still need the dot, or the 1, and I'm going to put a closed circle or a dot at that number, and it's smaller than or equal to that. Okay, and then the fourth one, greater than or equal to 0. In this case, I only need one number. I need 0 and that number that shows up, in which case this was 0. Since it's an or equal to, I fill in the circle, and the arrow is going to point to the right. So we use an open dot for less than or greater than, and a solid dot for less than or equal to, or greater than or equal to. The way I remember that is there's more stuff with those ones, so I have to fill in the circle. That's how I get my closed dot. So example 1, a city's record rainfall for the month of October is 16.8 inches. So far in October this year, 11.2 inches of rain have fallen. Find the average number of inches of rain that must fall each day to break the record if there are 14 days left in the month. All right, so we need to figure out, first off, what our variable is. Okay, so what are we finding? We're finding the average number of inches of rain, okay, each day. So my variable, I'm going to say x, is the average daily rainfall in inches. You can word that slightly differently, but you got to be saying that it's the average rainfall per day. All right, so if I want to break the record, if I'm breaking the record, I am not tying it. So it's not an or equal to. So I know I have a variable. I always want to keep my variables on the left if I can. I know it's got to get bigger than that. Okay, so it's got to get bigger than 16.8 inches. I need this number plus the rainfall that's already happened. And I've got 14 days left. So we've got to fill in some information. So I know for sure we've already had 11.2 inches of rain that's getting added to it. All right. I have an average daily rainfall in inches of X, but there are 14 days of those average daily rainfalls. So I'm going to have 14 times X plus 11.2 is greater than 16.8. When I solve, subtract 11.2. I'm going to treat it just like this thing was an equal sign and solve from there. So I've got 14x is greater than, when I subtract there, I've got 5.6. Divide both sides by 14. So I've got x is greater than, and in my calculator I'll put that this time, 5.6 divided by 14 is going to be 0.4. Okay, so the question was, find the average number of inches of rain that must fall each day to break the record. So to break the record, there needs to be an average daily rainfall of greater or more than 0.4 inches. Word problem gives me a word answer. All right, key part of this one that people are going to forget is that 14 days. Okay, if I just took the total rainfall that is the record minus what's already happened, that 5.6 is how much rain I need to get in order to break the record, but I'm asking for how much rain per day, not just how much rain. So that's where that 14 came into play. For this next one, we are going to graph this and solve. All right. So to solve, like I said, we treat this just like it's an equal sign. So my first step is plus 2 plus 2. So that gives me -4 greater than or equal to g over -5. I would multiply both sides by -5 to get a positive 20, and then this is going to be a g. Now, anytime we multiply both sides or divide both sides by a negative, this sign is going to flip around. All right? So this says 20 is less than or equal to G, which is the same thing as G is greater than or equal to 20. So I'm going to draw the picture, and then I'm going to show you guys exactly why it flips. So I need a 0. 20 would be somewhere over here. Okay, so I'm going to have a closed dot, and I got to go that direction. Now the reason why it's going to change, it's going to flip around. So I'm going to do -4 greater than or equal to G over -5 again. What I could do is I could add 4 to both sides, which would give me 0 is greater than or equal to G over -5 plus 4. And then I could add G over -5 to both sides. Okay, that would give me, or excuse me, I would add G over 5 to both sides, not G over -5, because these two things are going to cancel each other out. So that would give me G over 5 is greater than or equal to 4. Multiply both sides by 5. I got G greater than or equal to 20. That's why it flips around. When you're multiplying or dividing by a negative, it's just going to speed up the process of moving sides. On an equal sign, it doesn't matter. On a less than or greater than sign, it will make a difference. Example 3, a dance group charges $15 for membership. Members pay $8 for admission to monthly dances, and non-members pay $12. How many dances does Dave need to attend for the cost of membership to be less than paying as a non-member? So for this, there's going to be two different things we're looking at. Okay, the cost for a member and the cost for a non-member. And I want to figure out how many times they have to go. All right, so how many dances do you have to attend? So I'm going to say X is the number of dances attended. And then overall, we're still talking about cost. So I'm going to use cost for Y. Okay, so for a member, they have to pay, for their total cost, they have to pay $8 after, excuse me, have to pay $8 for every dance plus $15. So $8 per dance plus their $15 membership. Non-members, they don't have to pay that $15 membership. They just pay $12 for every dance. So those are my two things. But if they are both equal to Y, then I can say that 8x plus 15 has to equal 12x. If two things are equal to the same thing, they're equal to each other. Subtract 8x from both sides, and that gives me 15 equals 4x. If I divide both sides by 4, I've got x equals 15 over 4. And you're thinking, what does that mean? That tells me that if he goes to 15 over 4 dances, that they would be the same price. I have no idea about you guys, but I have no clue how you can go to 15/4 of a dance. Okay, I know that 16 over 4 equals 4, so this is 3 point something dances, right? I can't go to partial dances, so you can go to 3 dances or 4 dances. So how many dances does he need to attend to have the membership cost less? Remember, the less part is this one, okay? So if you're solving it equals, that's exactly what you do. I actually want this to be less than or equal to, okay? So how many dances would it be to cost less strictly? Less than or equal to would be fine. I made a mistake here with the or equal to. I don't want an or equal to. I want the member to be strictly less. Okay, so I need x to be less, or 15 over 4 is less than x, which means x would have to be greater than 15 over 4. So Dave would have to go to, and now the way this is worded can be very tricky. You could say more than 15/4 dances, but everyone will look at you funny if you say that in everyday conversation. So he would need to go to 4 or more dances for the membership to be cheaper. The way this one is worded is kind of tricky because the 4 or more implies that we have a less than or greater than or equal to, even though we don't have one in this case. But that's just because we rounded to the nearest whole dance. All right, so you'd have to go to 4 dances or more in order for the membership to be cheaper. Okay, setting those two things equal makes our life pretty easy if they want to be equal, but we want our member to be less. That's why we said the members are going to be less than the non-members. And now we're just going to graph a whole bunch of these. Okay, divide both sides by 5. That's a positive 5, so I don't change anything. It gives me a negative 4. So I need a 0. Negative 4 is to the left. Okay, open circle pointing to the right. This one here, I multiply. For whatever reason, I wrote a 2, but I don't multiply by 2. I multiply both sides by 4 to get x is less than or equal to 48. So I'm going to put a 0 here. I'm going to put a 48 here. I'm less than or equal to, so I color it in, point to the left. Minus 3 on both sides. Divide both sides by negative 2. Remember, when we divide or multiply by a negative, we flip that sign around. So I've got a 0, a negative 6 is over here. I'm closing the circle and pointing to the right. And then I'm going to add 7 on this fourth one. X over negative 3 is greater than 16. Multiply both sides by negative 3. When we multiply, we flip the sign to get x is less than, and then that's going to be a negative. 16 times 3 is 48. So I have a 0, a negative 48. Now, on a problem like this, I should give myself one more number. I'll say a negative 50 over here because my arrow is pointing this way. All right, so I need to have a 0. I need to have the number that the dot is at, and then if the dot has the arrow going away from it, not towards the 0, I need one more number. Does that make sense? Hopefully. Okay. Wherever direction the arrow points, there needs to be at least one number on that number line in that direction. Now for these, same thing. We're just going to solve first. There's multiple steps. We've done multiple step equations before. Now it's just an inequality. So I'm going to distribute to get 2x plus 10 greater than or equal to 7x plus 7. You can decide what side you want your x's on. I'm going to usually go to the left, but I'm always going to default to have a positive value. So I want a positive x, so I'm going to subtract 2x from both sides. That gives me 10 greater than or equal to 5x plus 7. Subtract 7 from both sides. 3 is greater than or equal to 5x. Divide both sides by 5. That gives me 3/5 is greater than or equal to x. Once you get to this point, all I'm going to do is basically read it backwards. X is less than or equal to 3/5. You just go and mirror what's happening. Obviously, you can't mirror the number, but one way to look at it is wherever this point is, that should still be pointing to the same number. So it's closer to x, it's got to be closer to x. Or if it was closer to the 3/5, it would have to be closer to the 3/5. So I need a 0, I need a 3/5. This is a closed circle, and it's going towards the left. Over here, you don't see a negative 1, but that is a negative 1, so make sure you distribute that. Gives me minus 2x minus 4. If I add 2x to both sides, I'm going to get a positive x on the left, which is going to be nice and helpful. Minus 6 from both sides gives me x is greater than negative 10. So 0, throw a negative 10 down here, open circle, pointing to the right. So your school soccer team is trying to break the school record for goals scored in one season. Your team's already scored 88 goals this season. The record is 138 goals. With 10 games remaining on the schedule, how many goals on average does your team need to score per game to break the record? Okay, so I'm going to say x is my number of goals per game. And I should say average number, so I'm just going to throw average in parentheses at the end here. So it's the average number of goals per game. I know that I have already scored 88 goals, and the record is 138. I want to break the record. I don't want to tie the record. So I need to get more than 138 goals. I already have 88. plus I've got 10 games left of scoring an average number of goals. Subtract 88 from both sides. I've got 10x is greater than 50. Divide both sides by 10 to get x is greater than 5. So your team needs to score an average of more than 5 goals per game to break the record. What I like about these inequality problems is that I don't actually need to know a specific value. I don't need to predict the future. I don't need to say they're actually going to score an average of 5.372 goals for the rest of the season. I don't care. I just need to know that they're going to score more than 5 goals per game if they want to set the record. They could score 4 goals one game, 10 goals the next game. I really don't care. I just care that they need at least 5 goals every game on average if they want to break that record. All right, so another example. Katie has $20 and she wants to buy bracelets that cost $1.30, but first she had to give her little brother $3. Write an inequality represents how many bracelets she can buy. So my variable x, you could use b for bracelets, you could use k for Katie, you could use whatever you want. Okay, this is going to be number of bracelets. Okay, number of bracelets that she's going to buy. So number of bracelets bought. She started with 20 bucks. Okay, so she cannot spend more than $20, but she can spend exactly $20. So I'm going to say it's less than or equal to 20 bucks. It's $1.30 per bracelet. Per bracelet means times. And she also gave her little brother $3. Okay, so I'm going to put a plus 3. Now you might say, but she gave it away, so it's subtracting. That's exactly what this first step is going to be. So it's going to be the same process. If you wanted to have written $1.30 x, and since I'm trying to say $1.30, I can't write it apparently, is less than or equal to, if you had written 20 minus 3 on the right side, it would have been the same thing. And now we divide both sides by $1.30 to get x is less than or equal to, if in your calculator you do 17 divided by 1.30, that's 13.0769238. I don't know what that would be for a bracelet. I don't really care. You can't buy a partial bracelet. You get the whole thing or you don't. Okay, so Katie can buy at most 13 bracelets. I'm rounding. I should say with the $20, with the money she has. I'm rounding, but I'm not saying, oh, it's a 0, so I round down. I can't get more than, I can't get a partial bracelet. Even if it was 13.99997 bracelets, it would be 13 bracelets. She can't afford that 14th bracelet. So I can say she could buy at most 13 bracelets, or she can buy less than 14 bracelets. Those are the exact same answer, even though the number is different. So this is where I want you kind of to think to yourself, like, how do we know which direction to draw the graph of an inequality, and how do we know whether the circle is open or closed? It's going to be a good spot for you to have a little bit of notes. And then here are a couple quick practice problems. So if you want to pause and then unpause and see how you did. So I'm just going to run through these very quickly. Divide by -1. That looks like a 7, but it gives us x is less than 1. So I've got a 0, a 1, open, to the left. -1 from both sides. Divide by -3. I divided by negative, so I flipped that around. So I've got x is greater than -7. Going that way. Now I need to distribute on this one, so I've got 5x minus 6x minus 42 is less than or equal to 3x plus 9. So that's a -x minus 42 less than or equal to 3x plus 9. I'm going to add x to both sides to keep it positive. So I've got negative 42 is less than or equal to 4x plus 9. Subtract 9 from both sides. That gives me a negative 51 is less than or equal to 4x. Divide both sides by 4. That gives me negative 51 over 4 is less than or equal to x. But I can flip that around like that. Okay, negative 51 over 4 doesn't simplify, so I know that I'm going to have 0 and negative 51 over 4 here. It's a closed circle, and we get bigger, so I go that way. All right. And that's it for the notes. Again, make sure you're looking at a few of the homework problems before you come to class. I hope everybody has a fantastic day.